So this is question 9 of the sample assessment materials at Edexcel GCSE higher physics paper, and this is getting towards the end of the paper, so quite tricky, but it is also quite a straightforward question about refraction. So 9a, explain what happens to the wavelength of light when it passes from air into glass. I'm going to think about the equation V equals F lambda. When light goes into glass, which is more optically dense than air, and more dense than air, not just optically, the speed of the light, because it's going through something that's thicker, will decrease. A fact to know is that changing density does not change the frequency of light. So if I slow down and keep the frequency the same, the wavelength must also decrease. So I just need to write that in words. So frequency stays constant, but wave speed decreases due to higher density. Therefore, wavelength decreases too, as V equals F lambda. Part B, figure 13 shows a beam of red light approaching one side of a rectangular glass block. The beam of light will pass through the block and leave through the opposite side. AB is a wavefront. Discuss the path of the wavefront AB as it enters and leaves the glass block, and this is a 6-mark question. Now, we know that the waves will look like this. They'll refract as they go through the block, and they're going to refract towards the normal to start with and away from the normal afterwards, but why? And it's because A reaches the block first. As glass is denser than air, A will slow down, while B is still travelling at the original speed. This will cause the ray to bend towards the normal until B has also entered the glass. A and B then travel at the same speed as each other, which is slower than before. So the ray is straight. At the glass-air boundary, the process is reversed. I'm going to go to here. A speeds up first as it hits the boundary first. You can see that there. So bends away from the normal. And I think that's a really nice 6-mark question. You've got to know your stuff, but if you know your stuff, it's a simple application. It's not even an application, it's just stating what happens. If you don't know your stuff, then obviously it's really tricky. Okay, part C. The distance between the Earth and the Sun is 1.5 times 10 to the 11 metres. Light takes 500 seconds to travel from the Sun to the Earth. The wavelength of red light is 670 nanometres. Calculate the frequency of red light using only the data provided. So they're doing this because they don't want you to use a constant. Now we need to work out frequency. We need to use the equation V equals F lambda, and we've been told the wavelength, that's 670 nanometres, but we haven't been told the speed. Now you could well remember the speed of light is 3 times 10 to the 8 metres per second, but they haven't told you that, therefore we can't use that approach. We need to work out the speed in a different way, and we do that using the age-old equation, speed equals distance over time. So the distance here is 1.5 times 10 to the 11, and we're dividing it by time, and the time is 500 seconds, which is how many minutes? I should know that. Let's just from interest. Oh, yeah, 8 minutes, so just about 8 minutes. So it takes about 8 minutes for light to get from the sun to the earth. I thought it was 8. So I'm going to work out the speed by doing 1.5 x, or times 10 to the 11, divided by 500. And it comes out as this very long number here. If I press eng, I get 300 times 10 to the 6, or if I looked at that more, it would be 3 times 10 to the 8. So I've shown the speed of light there, so 3 times 10 to the 8 meters per second. Then I can rearrange v equals f lambda to work out frequency. F equals v over lambda, which equals 3 times 10 to the 8 divided by 670 nanometers. And the easiest way to do that is to write times 10 to the minus 9 for nano. So I've got 3 times 10 to the 8 still on the calculator, divided by 670 times 10 to the minus 9. And F comes out as 4.4776, blah, 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 times 10 to the 14 hertz. And I'm going to round that to 2 or 3 sig figs. I'm going to go for 2, 4.5 times 10 to the 14 hertz. So I think quite a straightforward question, difficult in content, but not in application.